When watching a movie about space, we often see struggles or calculations between space empires that occupy many planets. Hello, everyone. Many people who try to predict the future may have the idea that one day in the future, even in the real world, humans will live on planets other than Earth. How close is this idea to reality? Also, if humans wanted to colonize the entire galaxy, how long would it take to achieve their goal? This is the Global Fields channel, and today we want to think about this question with you again. Let's start quickly. What is our purpose? Where to colonize? First of all, let's see why we need to leave the Earth where we live and migrate to other places. Such an effort requires a lot of money. Even if the right technology is really developed, it will be very expensive, and this will not change in the next few centuries. Therefore, even if humans could colonize other planets, no sane nation would make this decision. In early science fiction, overpopulation was often cited as one of the reasons for colonizing other planets. However, this threat factor may actually be overestimated. First, as the second half of the 20th century showed, birth rates in developed countries are on the decline. The population of developing countries is still growing, but the rate of growth is slowing down. In addition, as these countries develop, people no longer need to have 10 children to raise 3 children to adulthood. By the second half of the 21st century, the world population may stabilize at around 12 to 15 billion people and will not increase much further. Even if the population increases, it may increase at a very slow rate, similar to that of rich developed countries. Second, we should not measure the entire Earth by the standards of large cities. The Earth we live on still has a lot of undeveloped land. No, we do not mean that everyone should give up everything and move their families to Zenyilan in Siberia, Taiyuan in Canada, the Sahara Desert, or the Amazon jungle. However, there are still many people who choose to move to small towns or rural areas. For these people, the biggest problem is how to get welfare, education, quality healthcare, and general leisure activities. However, with the advancement of science and technology and the development of transportation networks, these problems can be solved. If you can go to work or school in a big city on a high-speed train reaching speeds of 500 kilometers per hour, you can also choose to live in a beautiful town surrounded by fields and forests. The main reason for colonization is not the urgent need to move surplus people to other places. The main purpose is to make money from resources. There are extremely rich resources in the universe. The solar system alone can provide all the resources needed for human industry for thousands of years, and it will not destroy the Earth's environment as it does now. Therefore, the occupations of future colonists will be very simple. They can be engineers, planetologists, and workers in charge of mineral mining stations. However, we will face another problem here. Except for the Earth, there is no celestial body in the solar system where humans can survive outdoors. Even if we are lucky enough to discover a planet similar to the Earth, it does not mean that we can live freely outdoors. Humans are very fragile creatures. Among a large number of large G and various other parameters, the range in which we can feel comfortable is very limited. The slight difference in gravity, the length of the day is different. The difference in atmospheric pressure, the trace amount of toxic gases contained in the air, all these conditions will lead to the most serious consequences for the physical and mental health of the colonists. Also, if you just want to exploit resources, it's not very suitable to do it on a planet, because you have to go into orbit, unload the necessary cargo from there, conduct various geological surveys, dig tunnels and other bases, and after obtaining the minerals, you have to pull them out of the gravity well in some way. Mining on an asteroid is much easier because you don't have to worry about gravity or the surrounding environment. In addition, even if the resources of the asteroid are exhausted, there is no need to mobilize a large number of people to move to a new asteroid if it is not necessary. On the contrary, the next new asteroid can be attracted to the place close to the base. Isn't it convenient? In short, when we carry out colonization, we should focus on systems with many asteroids, rather than inner planets. In this case, the most suitable place seems to be a young star surrounded by a star-purple cloud and has not yet formed a planet. It is very difficult to spend a lot of time working in space, and not everyone is able to cope with it. Therefore, it is best to minimize the human factor as much as possible. Before finding a convenient method of superluminal navigation, this is also an extremely urgent problem for other star systems. For example, from the most realistic part, not many people are willing to spend their entire lives to move to the new Vega system. Therefore, the main colonists from the Earth are likely to be robots. We already know that it is easier and more convenient to use automated probes to explore space than to send humans to other celestial bodies. This situation should not change in the future. But if we want those robots to be able to do more than just photograph other planets and moons, and occasionally collect samples from the surface for research, then we have to equip them with full artificial intelligence and greatly expand their capabilities. We need to give the AI that controls automated warfare some important instructions. First, the AI must be able to discover mineral deposits, and second, it must have the ability to develop mining infrastructure on its own. Third, we want them to be able to repair faults on their own and replicate themselves when necessary, creating new research robots, construction robots, mining robots, and cargo drones, which requires extremely high functionality. In other words, what we want to create is almost completely artificial life. A robot mothership arrives at the next star system, evaluates whether there are useful resources in that system, and then begins to arrange resource extraction and transportation to Earth. Next, create a copy of itself, send it to another star system, and repeat the same process there. This self-replicating spaceship already has a name, that is, the von Neumann spaceship. In theory, we already have some of the knowledge needed to start building such spaceships. The problem is the technical ability to implement this plan, but it is likely to be solved within the next 100 years. For example, when a von Neumann spacecraft is sent to Proxima Centauri, the entire process will automatically start. The spacecraft arrives at the nearest horizontal line and sends 2 copies of itself to other nearby horizontal lines. This copy also creates 2 copies of itself, and this process will be repeated continuously. Of course, without superluminal navigation, the colonization of the Milky Way should be very slow at first. However, with the progress of various fields, the number of development systems has begun to grow exponentially. Don't underestimate a small number. I wonder if you have heard of the story of the inventor of chess asking the king for a reward? Put 1 grain of wheat in the first square of the chessboard, and 2 grains of wheat in the next square. Put 4 grains of wheat in the third square, 8 grains of wheat in the fourth square, and so on. Assuming there are 64 squares on the chessboard, if there are viewers who want to solve the problem by themselves, please carefully calculate how many grains of wheat the wise man asked for. Now, let's be clear. Even if you spread seeds all over the Earth, or even the entire solar system including the Sun, you probably wouldn't be able to collect such a huge number. The same is true for star systems. The scale and speed of the colonization process by von Neumann spacecraft will increase as you go further and further, and this will continue until there are no unexplored star systems in the Milky Way. Even if the cycle of arrival, development, replication, and dispatch of new spacecraft takes a world, it's not a long time on an astronomical scale. As for how long it would take to colonize the entire Milky Way, there are many estimates, ranging from 500,000 years to millions of years. It does seem like a long time, but as I just said, it's not that long on a cosmic scale. It's only about the number of years the youngest stars survive. By the way, it seems that no other foreign probes have entered the solar system so far, and no celestial bodies in the solar system have been touched. All of these things mean that, at least in this galaxy, we may indeed be the only ones. But that will be the subject of another video. Now please rest assured that even if there are no other intelligent companions in our galaxy, the entire Milky Way and even the local group of galaxies will eventually fall into our hands. If we can defeat aging and death in the future, Perhaps our descendants can achieve this great human achievement in the near future. If you like this video, please help to secretly like and share it on social networking sites with your relatives and friends. Thank you very much for your help. Let us look forward to the next video together. Goodbye.